To solve equations with variables on both sides, let's look at an example first to see what we need to do. So here's the example. So solve the equation 5x plus 3 equals 2x minus 9. Okay, so every equation that we've looked at so far has involved a pronumeral on one side and maybe a number, maybe a number on both sides perhaps. But we've only ever had the one pronumeral. Now we've got two pronumerals, okay, or two variables. One on one side, one on the other, okay? And so this is where we need to add an extra step to reduce the equation down to one pronumeral instead of having two pronumerals on either side. So the general rule is that we move pronumerals to the left, okay, and numbers to the right of the equal sign. So let's go to our original example, okay? So we've got 5x plus 3 equals 2x minus 9. Now the 5x is in the right place. We don't have to do anything with that. The negative 9 is also in the correct place. It's on the right-hand side. But the positive 3 and the positive 2x are on the wrong side. So we actually need to switch these over. So the 2x really needs to come back to this side. And if the 2x is originally positive, it becomes a negative. Okay, so it moves over. Okay, so we move it over to the other side. And the positive 3, when we move it over to the other side, okay, so from the left to the right, the sign switches as well. So it turns from a positive 3 into a negative 3. Okay, so just remember, and a good rule to remember with equations, that if you move something from one side to the other, okay, just with addition and subtraction, okay, with multiplication and division, it's a bit different. So if something is being added on one side and you move it over to the other, it needs to be subtracted. Okay. Okay, so let's write the next line of the equation in. So we have 5x minus 2x, okay, is equal to, now the negative 9 stays where it is, okay, it's anchored in place, it doesn't have to move, okay, so it stays on the left-hand side. Now we're going to subtract another 3, okay, that this positive 3 moves over and becomes negative 3. So let's solve this now. Now it's a lot easier now to solve this equation. 5x minus 2x, collect the like terms, we get 3x. Okay, negative 9 minus 3 is negative 12. Now it becomes a one-step equation. We divide both sides by 3, or we move the 3 over, it becomes a division by 3. So x is equal to negative 12 over 3. Therefore, x is equal to negative 4. Okay. Now we can test this, and we should test it. If you were to substitute negative 4 into both sides of the equation, you should get the same value on both sides. So if you substitute negative 4 into the left-hand side, 5 times negative 4 is negative 20. Negative 20 plus 3 is negative 17. Let's see if it works on this side here if we get negative 17. 2 times negative 4, so imagine the negative 4, put that in, substitute it in for x. 2 times negative 4 is negative 8. Negative 8 minus 9 is negative 17, so that works. Let's have a look at a couple more examples. Okay, so let's solve the following equation. So if you like, you can pause the video at this point, copy the examples down, okay, have a go at it, and then have a look at the work solution after. Okay, so I'm going to go through now and do the work solution. Okay, so 7x plus 2 equals 10 minus x. So what I'm going to do is this negative x here, I'm going to move it over, and it's going to become a positive x. Okay, the 10 is already on the correct side. It's already on the right-hand side. So the 10 can stay where it is. The positive 2 on the left becomes negative 2 on the right. Okay, good way to think of it actually. Left, right, so everything's opposite. So when you move something from one side to the other, it just becomes the opposite of what it was. So 7x plus x is 8x. 10 minus 2 is 8. Therefore, now we can divide, we can move the 8 over, it becomes, so x is equal to 8 over 8, which is just 1. Okay, so the 8 moves onto the 8 there, becomes a division, becomes 1. Okay, and part B, 5 minus 4y equals negative 25 minus 19y. Now it works with negatives as easily as it works with positives. Okay, negative numbers should not be feared. Okay, we work with them exactly the same way we work with positive numbers. Okay, they're just numbers. We've just got to be careful with the negative sign, that it stays with the term after it. Okay, so now the negative 4y is in the right place, so we can leave that there. Okay, so negative 4y. Okay. The negative 19y on the right is in the wrong place, so this needs to move over. This term here, okay, it needs to move over to the left-hand side. So negative 19y, when it moves over, becomes positive 19y. Okay, now the negative 25 originally is already in the right place, so that can stay where it is. We have a 5. Now, if there's no sign next to the 5, so to the left of 5, we assume the 5 obviously to be a positive. So when the positive 5 moves over, it becomes a negative, of course. Okay, so negative 4y plus 19y is going to be 15y. And negative 25 minus 5 is going to be negative 30. Okay. Now, we move the 15 over, it becomes a division because 15y means 15 multiplied by y. So sort of always remember with algebra, there's like an invisible multiplication symbol there. And so that's going to be negative 30 over 15. Therefore, y is equal to negative 2. And of course, you can substitute that negative 2 into both sides of the original equation and just check that the left-hand side, in fact, does equal the right-hand side. And I imagine it would. Actually, let's test it while we can. Positive 5 minus 4 times negative 2. Positive 5. So minus 4 times negative 2 is positive 8. So positive 5 plus 8, that's you're going to get 13 here. And negative 25 plus 19, sorry, minus 19 times negative 2 becomes a plus. So negative 25 minus 38. Okay, so it becomes negative 25 plus 38. You also get 13 as well, so that most certainly does.